Hello students, today we will discuss about a very interesting topic of your science book, that is motion. In this topic we will discuss about the terminologies of motion, equation of motion and graphical representation of motion. Motion. To know details about motion, we must have a central idea regarding position, origin or reference point, speed, velocity, acceleration. What is position? Position means location. Where is it? Origin or reference point. It is the location from which distance is measured. My house is 5 km from bus stand towards east. Here direction is present. House location or position. Bus stand is the reference point or the origin. From bus stand my house is 5 km. Towards east, direction is there. So reference point or origin and direction both are required to get the position of a body. To locate the position of a body, we have to stress on two things, that is the origin and direction. Origin or the reference point and direction. Position in straight line motion. To study about the position in straight line motion, we must have a central idea regarding the number line. What is number line? In previous class, we have studied about the number lines. 0 is the origin or the reference point. Towards right, all positive numbers. 1, 2, 3, 4, 5, 6, etc. And towards left, -1, -2, -3, -4, -5, etc. Suppose the position of two persons, this blue person and the red person. Blue person, this person is 3 km from origin towards east, from origin towards east. This red person is 2 km from origin towards west. Magnitude is 2 km and 3 km respectively, but direction is west and east. Positive or negative sign of position represent direction only. If a body or its parts changes its position according to time, then it is said to be in motion. Distance. The actual path covered from initial position to final position. That means a person starts moving from A and through B goes to C. The actual path he covered is the length of AB plus BC. But the shortest path between the initial point A and final point is AC. So AB plus BC, this path, this is the distance between A and C. Between A and C, the distance is AB plus BC, but displacement is the length of AC. So the actual path covered from initial position to final position, AB plus BC is equal to distance, AC is equal to displacement. What is displacement then? The shortest path between initial and final position. Vector and scalar quantities. Scalar quantities having only magnitude. Vector quantities having both magnitude and direction. These are the vector quantities: displacement, weight, force, acceleration, velocity. Scalar quantities are distance, mass, density, temperature, speed, energy, power, etc. Why? These are the scalar quantities and these are the vector quantities. Here only magnitude is present and here both magnitude and direction are present. From the above discussion, we confirm that the displacement is the distance in certain direction. From displacement, velocity is derived. Displacement by time is velocity. So velocity is also a vector quantity. From velocity, acceleration is derived. Rate of change of velocity is known as acceleration. So acceleration is also a vector quantity. What is force? Force is equal to mass into acceleration, m into a, mass into acceleration. Though acceleration is a vector quantity, force is also a vector quantity. So these are the vector quantities and these are the scalar quantities. In scalar quantities, density, mass, temperature. Temperature having no direction. 34 degree temperature. We cannot say 30 degree temperature towards east or towards east-west or towards north. Not like that. Only magnitude is present. That means a numerical value and a unit. The physical quantities which are specified with magnitude or size alone are called scalar quantities, and the physical quantities having both magnitude as well as direction are called vector quantities. Vectors are specified by magnitude, a number and a unit, but scalar is specified by only a number and a unit. Then we will study about speed, velocity and acceleration. What is speed, what is velocity and what is acceleration. These are the terms related to our topic. From this we will derive the equation and study about the graphs also. Speed means the average speed is the distance divided by time. Speed is distance divided by time. Suppose a motorcycle starts from Jagatsinghpur and reach at Cuttack in 3 hours. The distance between Cuttack and Jagatsinghpur is 50 km. It takes 3 hours. So 50 km divided by 3 is the speed of that vehicle. Velocity is speed in a given direction. Speed and velocity. Speed is the distance divided by time. Velocity is the speed. This is also a speed. Velocity and speed are same thing, but in velocity there is a specified direction. Acceleration is a change in velocity divided by time. Velocity changes according to time. It's called acceleration. If velocity will not change, there will be no acceleration. Speed means how fast a body is moving. Yes, definitely. Speed. Sometimes we say that the motorcycle is moving in very speed. The motorcycle is moving in slow motion. That means it changes its position frequently, speedily. Change of position according to time very quickly is speed. Speed means how fast a body is moving. Speed means rate of change of position. Speed having a direction is called velocity. Yes, we have discussed earlier. So velocity is the rate of change of position of an object with respect to a reference. The reference is required or the origin is required by which we can calculate the speed. So the formula is speed is equal to distance by time, or distance is denoted by s and time by t. So s by t, the unit of s or the distance is meter and time is second. So meter per second or meter second inverse. Velocity is the same unit as like speed. Velocity is equal to displacement by time. That means s. This arrow mark indicates the direction. Displacement by time. So meter per second, that is equal to meter second inverse. Acceleration is the rate of change of velocity. A is equal to v by t. V is equal to m by s is equal to m by s square. Velocity time graph. The rate of change of velocity may be increasing or decreasing. If the velocity changes in an increasing order, then it is called acceleration. If it decreases, then it is called retardation. Graphical representation. Graphical representation, distance time graph and velocity time graph. Concentrate it and you can clearly understand the fact. This is the distance time graph and this is the velocity time graph. In distance time graph, we have taken time in x-axis and distance in y-axis. Suppose time interval is 10, 20, 30, 40, 50, 60, 70, etc. in second. And the distance in meter is 10, 20, 30, 40, 50, 60, etc. If we say that a body is in 30 meter apart from the origin in 10 seconds, and also 30 meter apart from the origin in 20 seconds, in 30 seconds also there, 40 seconds is also in there, 50 seconds is also in that place, 60 seconds also in that place. That means that body is in rest. There is no movement of that body. Body is in motion. Body is in rest. And in uniform motion, we can say that a body is in uniform motion. When 9-10 seconds, the body is in 10 meter apart from origin. In 20 seconds, 20 meter. In 30 seconds, 30 meter. 40 seconds, 40 meter. 50 seconds, 50 meter. 60 seconds, 60 meter. 70 seconds, 70 meter. That means according to the time, the body changes its position uniformly. The time gap is 10 seconds and the distance gap is 10 meter. So the body is in uniform motion. When a body will be in non-uniform motion, in non-uniform motion, suppose in 10 seconds the body covers the distance 10 meter from the origin. In 20 seconds it should be 20 meter from origin in case of uniform motion. But in case of non-uniform motion, what happens? In 20 seconds it covers 30 meter distance. In 30 seconds it covers the distance 70 meter. That means there is no uniformity in motion according to time. So this motion is known as a non-uniform motion and the graph will be like this, curved line. But in case of uniform motion, the graph is a straight line. As like that, in case of a velocity time graph, we can take time in x-axis and velocity in y-axis. What happens? Last second, the body is 3 meter apart from origin. In 2 seconds, the body is 3 meter apart from origin. In 3 seconds also 3 meter apart. 4 seconds 4 meter. 4 seconds 3 meter. 5 seconds 3 meter. 6 seconds 3 meter. That means the body is moving in a uniform motion. In velocity time graph, the straight line parallel to x-axis indicates the body is in uniform motion. But in case of a distance time graph, the straight line from origin, this graph indicates uniform motion. See this graph? In this case also we have taken time in x-axis and velocity in y-axis. A body covers a distance of 10 meter in 10 seconds, 20 meter in 20 seconds, 30 meter in 30 seconds, 40 meter in 40 seconds. Like this, if we join the dots, the graph will be like this. What this graph indicates? You see, the time interval is 10 seconds. In each 10 seconds, the body moves 10 kilometer, 10 kilometer, 10 kilometer distance. That means the body is uniformly accelerated. That means in each 10 seconds, the body moves 10 kilometer or 10 meter or 10 centimeter. That means the body is uniformly accelerated. In case of a non-uniformly accelerated body, see this graph, time in x-axis and velocity in y-axis. What happens? Suppose in 1 second body covers 1 kilometer. In 2 seconds it should cover 2 kilometer if it is uniformly accelerated motion, but though it is non-uniformly accelerated motion, in 2 seconds it covers distance 3 kilometer. In 3 seconds it covers the distance 5 kilometer. In this case, graph will be like this. In case of a non-uniformly accelerated motion, the graph will be like this. That means the body changes its position not in a uniform manner. Thank you.